Welcome back, guys. In previous sessions, we have discussed about conventional circuit breakers, which are of air brake, air blast, oil, and SF6 as well as vacuum circuit breaker we have discussed. So, if you see the applications of these circuit breakers, these are used above 1 kV. These circuit breakers are used above 1 kV. For below 1 kV, what are the circuit breakers uh, we will use? So those are of MCBs, MCCBs. For earth leakage protection, we will use earth leakage circuit breaker and RCCB. In this class, we will discuss about miniature circuit breakers. Right. So at the end of this session, you will get the basic idea about what is the operation of miniature circuit breaker and what is the working of miniature circuit breaker. Selection of MCBs based on its operating curves. This is the miniature circuit breaker. We are frequently seeing this miniature circuit breaker in our households also. If you open the distribution box which is available at the main, we can see many MCBs. Now let us see in detail discussion about MCBs, that is miniature circuit breakers. What is miniature circuit breaker? How it will be worked? A miniature circuit breaker is a automatically operated electrical switch designed to protect an electrical circuit from damage caused by excess current. Damage caused by excess current. So these excess current may be because of overloading or because of short circuit. Because of overloading or because of short circuit. And its basic function is to interrupt the current flow after the fault detection. It will interrupt the current flow after the fault detection. For example, if I have taken fuse, in case of fuse, what we need to do? We have to replace the fuse for every protecting operation. Whenever the fault occurs or whenever there is overloading occurs, the fuse will be burnt and we need to replace the fuse. But in case of MCB, it need not requires. Whenever there is excess amount of current because of either overloading or short circuit, circuit will be tripped and it will be reconnected, or a circuit breaker can be reset either by manually operating or automatically operating. Right. So this is about MCB. Now let us discuss about what are the parts of MCB, that is construction about miniature circuit breaker. In MCB we have incoming terminal, arc chute, bimetallic strip, magnetic coil, copper braid, on off switch and outgoing terminal. So if you observe here, we have incoming terminal, the top one is the incoming terminal, and so this is the incoming terminal. So this incoming terminal will be connected by a wire. For example, this is supply. For example, this is supply, which is phase. Right. So this phase wire will be given to incoming terminal, and at the end of this MCB, same wire will be returned. Basically, we are using switching operation in phase terminal only. For example, if it is single phase, we use only in phase, or if it is in three phase, we need to use 3 MCBs for each phase. Right. So this is incoming terminal and this is outgoing terminal to connect electrical wires. And the next one is whenever the current is exceeds the limit, whenever the current is exceeds the limit because of overloading, what happens? There is a special mechanism is there, that is bimetallic strip. The strip will be expanded. If you observe here, this strip will be expanded or contrasting based on the current which is flowing through the bimetallic strip. For example, if it is overloading, the current is exceeds the limit, the bimetallic strip will be expands because of heating effect, and it will be open circuit the circuit by providing trip signal. by providing trip signal. That means the on off switch will be tripped down whenever the bimetallic strip is expanded. Now, so this is for overloading. During fault conditions, the current will be suddenly increased, right? The current will be suddenly increased. Within no time, the current will be reaches to multiple times of rated current. So, if still for the short circuit current, if you use bimetallic strip, what happens? The bimetallic strip will take some time to expand, right? To expand or to contrast either. So, as the bimetallic strip is a mechanical component, as the mechanical component, it needs to expand while any faults occur. It will take several time to expand, right? So, in this time, the equipment which is connected will be damaged because of that fault current. Then what is the use of circuit breaker, even though if you are not protecting from short circuit faults? Right. So that's why we use a magnetic coil. We use a magnetic coil. So because of this magnetic coil, whenever the current is drastically changed above the certain limit, so this magnetic coil will produce a signal. That means it will be either attraction or repulsion. Because of this, the bimetallic strip will be open and the circuit will be open. So that is the operation here. During on off condition, there may be a chance of occurrence of arc also, right? So to quench this arc shoot will be useful. We have seen what is arc shoot in case of air brake circuit breakers and air blast circuit breakers. Right. So similarly, in this also, the arc shoot is used to quench the arc whenever there is a switching occurs. The one more part is there, that is copper braid, which is used to connect the circuit and magnetic coil. Right. So these are the construction parts of a MCB. This is the practical MCB. We can observe here. We have this on-off lever, that is on-off mechanism, and we have contacts. That means incoming terminal and outgoing terminal. Here is this is outgoing terminal and this is incoming terminal. This is incoming terminal and this is outgoing terminal. And we can see this. We can see here thermal magnetic strip, which is a bimetallic strip. Here you can observe. It is the thermal bimetallic strip, thermal magnetic strip. Here we have V-shaped. Here we have V-shaped thermal as well as magnetic strip. And this is the actuating quantity. This is the actuating quantity. For example, if you observe here, whenever the current increases because of overloading, so this bimetallic strip will be expands. Because of this expansion, the mechanism will be pulled out from the circuit, so the contacts will be open. The operation we will discuss in next slide. And also we have one magnetic coil. This is the magnetic coil, which will provide magnetic flux for short circuit valves, during short circuit valves. Right. So this is the practical view of a circuit breaker. Now let us come to working principle of miniature circuit breaker. Working principle of miniature circuit breaker. So as we are discussing, the miniature circuit breaker works based on the thermomagnetic effect. I am repeating, it is based on the thermomagnetic effect. Right. So the most important thing that circuit breaker is doing is safely and reliable switches of electrical circuit during abnormal conditions of a network. That means overloading condition as well as faulty condition, right? Under normal working condition, the circuit breaker work when we switch operator manually from position on to off, right? This MCB can be used either of the protection, that means overload protection and fault protection, as well as for manual operating. For example, if you want to do any maintenance in our existing electrical network, what we need to do? We just switch off the supply of one room, right? So that's why during maintenance, we need to have a provision to switch on or off the network. That's why MCB is also used as switching mechanism from position off to position on or vice versa. Here we have two contacts, fixed contact and moving contact. Now let us come to case 1, that is overloading condition. Under overloading condition, the current through the metallic strip causes the rise of temperature of it, right? So the heat generated within the bimetallic strip is enough to cause deflection due to thermal expansion of metals, right? This deflection further releases the trip latch and contact gets separated. I am repeating, in case of overloading condition, the first case, the current through the metallic strip causes the rise of temperature in it, which is caused for deflection of thermal expansion. That means bimetallic strip has been expanded, the metal contacts will get separated. The metal contacts will get separated. So this is the first case, that is overloading condition. Using this contact separation to quench the arc, we use arc chute. The next one is during faulty conditions. During faulty condition, what I have discussed, because of this electromagnet is provides either attraction or repulsion, that is based on manufacturer purpose only, right? So by either by providing attraction or repulsion force, the contacts will get separated. The contacts will get separated. So observe this video, right? So it is the bimetallic strip what I have discussed. This is the bimetallic strip what I have discussed, and this is the magnetic coil. Now whenever the current exceeds the limit, that means during faulty conditions or during overloading conditions, it will be pulled. Observe here, the strip will be pulled and the contact gets separated. And the contact gets separated. I am repeating the video. See here once. I am repeating the video. See here once. Now, this is the bimetallic strip which I had during overloading conditions. The bimetallic strip get be expanded, or during faulty conditions because of this magnetic coil, the strip will be pulled out. Hence, the contact will be separated with the help of this actuating mechanism. You can observe here, right? So the strip was pulled here, the strip was pulled here, and there is a separation of contacts. I'm repeating. So because of that magnetic pull, the actuator quantity helps to separate the contacts, these two contacts. So to quench the arc which is generated in between contacts, we use arc chute, right? So this is the operation of miniature circuit breaker. Now let us come to types of circuit breakers, miniature circuit breaker according to the operating ranges, right? So the miniature circuit breaker is classified in major types according to instantaneous stripping. According to the instantaneous stripping currents, they have classified as type B, type C and type D. Now let us go to in detail discussion about each one. The first one is type B. The first one is type B. So in this type, the trip is instantly produces at a rate of 3 to 5 times of rated current. That means the trip signal will be, or this MCB is rated for up to withstand a amount of 3 to 5 times of rated current. Right, these are normally used for resistive or small inductive loads where switching surges are very small. Therefore, these are suitable for residential or light commercial installations. Right. So observe here, this is the main point here. In case of type B, it will be rated for 3 to 5 times of its rated current. 3 to 5 times of its rated current. So you can observe here, this is 3 and this is 5. If you observe the time current curve, it will be capable of withstanding 3 to 5 times of rated current. So this is the overloading condition. This is the overloading condition. The current is slightly increasing. So under this condition, because of thermal effect, the bimetallic strip will be open, so the two contacts of fixed contact and moving contact will get separated. But you can observe here, it is the very drastical. This is the short circuit fault. This is the short circuit fault. So in this fault, within no time, whenever the fault occurs, within no time, the current is increases all of a sudden. So all of a sudden. So if this current is in between 3 to 5 times, we use type B MCB. Or if this current is in between 5 to 10 amperes, that means 5 to 10 times of rated current. If this current is 5 to 10 times of rated current, so type C MCB will be used. Type C MCB will be used. So this is used for high inductive loads where the switching surges are high. This is used for high inductive loads where switching surges are high, like small motors in fluorescent lighting, or in such cases type C is preferable. Type C is preferable to handle higher value of short circuit current. Right. So therefore these are used highly inductive commercial or industrial applications. Right. This is about type C MCB, which is used for the rating which is 5 to 10 times of rated current, which is rated for 5 to 10 times of rated current. And the next one is type D MCB. So in this case, it can withstand a short circuit current of 10 to 25 times. It can withstand fault current of 10 to 25 times of rated current. So this can be used very high inductive loads. It will be used for high inductive loads where high inrush currents or very frequency of these suitable for specific industrial loads and commercial applications. Right, like you can observe X-ray machines or UPS, X-ray machines, UPS systems, or industrial weldings, or large winding motors. For this protection, type D MCB will be used. Now, these type B and type C or type D, these are only used for AC systems only. If you observe type K MCB, it will be useful for both AC and DC as well. In case of AC, it can be capable of withstand 8 to 12 times of rated current if it is used in case of AC, or if it is used in case of DC, it is far more. It is far more. It is operate up to 18 times in case of DC. So similarly, in case of Z also, in case of class Z MCB is also, it can be used for 2 to 3 times of rated current. It can be stand up to 2 to 3 times of rated current, and it can be also used for AC as well as DC. If you observe these two, the same circuit breaker can be operated at high amount of DC rather than AC. Right. So because we know in case of AC we have all other components like RMS, maximum, like that. But in case of DC, we have only average current. Right. Now let us come to different characteristics here. If you observe,
characteristics show a thermal trigger for overloads and a magnetic trigger for short circuits. Different tripping characteristics for MCBs exist. such as D or C, with B being the type most commonly used. For instance, a B1 rating means that the MCB will instantaneously trip currents in between 3 to 5 times the nominal current, with the nominal current being 1 amp. Inside of an MCB, the path the current is taking across the closed contacts is visible, as are the tripping components. The higher the amplitude of the overcurrent, the faster an MCB must trip. This is achieved with a metallic element consisting of two different metals, which are heated up by the current flow. The two metals are expanding at different rates while they're heating up. An overcurrent that is present long enough will eventually activate the braking element. An MCB must open a circuit instantaneously when it encounters a short circuit at several times the nominal current. A solenoid and a piston are the elements used for instantaneous tripping. A short circuit creates an instant magnetic field that moves the piston and operates the breaker. Interrupting high fault currents can result in heavy arcing. Due to magnetic forces, the arc moves through a stack of metal plates where it is cooled, split, and finally extinguished at the next zero crossing. Despite its small size, an MCB has a rather sophisticated design consisting of two separate tripping mechanisms for overloads and short circuits.
Observe the ratings of MCB. For example, if you want to withstand up to 5 to 10 times of rated current, we use type C MCB, or if you want to withstand up to 3 to 5 times of rated current, we use type D MCB. If it is more than 10 to 10, that means 10 to 25 times of rated current, we use type D MCB for AC. For DC, we use either type K or type Z according to the characteristics.